Hey, this is Sleeper. Welcome back to my channel. We are continuing the bug bounty job role path with SQL injection fundamentals. If you need access to Hack the Box Academy, I definitely recommend the Silver annual plan, as it gives you direct access to all the modules up to Tier 2 and the entire job role paths of the SOC Analyst, Penetration Tester, and the Bug Bounty Hunter, and also includes an exam voucher, which is good for 2 exam attempts. When it mentions up to Tier 2, most of the modules in the job role paths are within 0, 1, and 2, but there are additional modules that might not be in those job role paths that you might be interested in. So let's go ahead and get started with our next module, with our introduction. SQL Injection Fundamentals. Most modern web applications utilize a database structure on the back end. Such databases are used to store and retrieve data related to the web application, from actual web content to user information and content, and so on. To make the web applications dynamic, the web application has to interact with the database in real time. As HTTP or HTTPS requests arrive from the user, the web application's backend will issue queries to the database to build the response. These queries can include information from the HTTP or HTTPS request or other relevant information. When user-supplied information is used to construct the query to the database, malicious users can trick the query into being used for something other than what the original programmer intended, providing the user access to query the database using an attack known as SQL injection or SQLI. SQL injection refers to attacks against relational databases such as MySQL, whereas injections against non-relational databases, such as MongoDB, are NoSQL injection. This module will focus on MySQL to introduce SQL injection concepts. SQL injection, or SQLI. Many types of injection vulnerabilities are possible within web applications, such as HTTP injection, code injection, and command injection. The most common example, however, is SQL injection. A SQL injection occurs when a malicious user attempts to pass input that changes the final SQL query sent by the web application to the database, enabling the user to perform other unintended SQL queries directly against the database. There are many ways to accomplish this. To get a SQL injection to work, the attacker must first inject SQL code, and then subvert the web application logic by changing the original query or executing a completely new one. First, the attacker has to inject code outside the expected user input limits, so it does not get executed as simple user input. In the most basic case, this is done by injecting a single quote or a double quote to escape the limits of user input and inject data directly into the SQL query. Once an attacker can inject, they have to look for a way to execute a different SQL query. This can be done using SQL code to make up a working query that executes both the intended and the new SQL queries. There are many ways to achieve this, like using stacked queries or union queries. Finally, to retrieve our new query's output, we have to interpret it or capture it on the web application's front end. Use cases and impact. A SQL injection can have a tremendous impact, especially if privileges on the back-end servers and database are very lax. First, we may retrieve secret or sensitive information that should not be visible to us, like user logins and passwords or credit card information, which can then be used for other malicious purposes. SQL injections cause many password and data breaches against websites, which are then reused to steal user accounts, access other services, or perform other nefarious actions. Another use case of SQL injection is to subvert the intended web application logic. The most common example of this is bypassing login without passing a valid pair of username and password credentials. Another example is accessing features that are locked to specific users, like admin panels. Attackers may also be able to read and write files directly on the back-end server, which may, in turn, lead to placing backdoors on the back-end server and gaining direct control over it, and eventually taking control over the entire website. Prevention. SQL injections are usually caused by poorly coded web applications or poorly secured back-end server and database privileges. Later on, we will discuss ways to reduce the chances of being vulnerable to SQL injections through secure coding methods like user input sanitization and validation, and proper back-end user privileges and control. Intro to databases. Before we learn about SQL injections, we need to learn more about databases and SQL, structured query language, which databases will perform the necessary queries. Web applications utilize back-end databases to store various content and information related to the web application. This can be core web application assets like images and files, content like posts and updates, or user data like usernames and passwords. There are many different types of databases, each of which fits a particular type of use. Traditionally, an application used file-based databases, which was very slow with the increase in size. This led to the adoption of Database Management Systems, DBMS. Database Management Systems. A database management system, DBMS, helps create, define, host, and manage databases. Various kinds of DBMS were designed over time, such as file-based, relational DBMS, or RDBMS, NoSQL, graph-based, and key/value stores. There are multiple ways to interact with a DBMS, such as command line tools, graphical interfaces, or even APIs, application programming interfaces. DBMS is used in various banking, finance, and education sectors to record large amounts of data. Some of the essential features of a DBMS include concurrency, which is a real-world application. A real-world application might have multiple users interacting with it simultaneously. A DBMS makes sure that these concurrent interactions succeed without corrupting or losing any data. We have consistency. With so many concurrent interactions, the database management system needs to ensure that the data remains consistent and valid throughout the database. Security. DBMS provides fine-grained security controls through user authentication and permissions. This will prevent unauthorized viewing or editing of sensitive data. Reliability. It is easy to back up databases and rolls them back to a previous state in case of data loss or a breach. And structured query language. SQL simplifies user interaction with the database with an intuitive syntax supporting various operations. Architecture. The diagram below details a two-tiered architecture. Tier 1 usually consists of client-side applications, such as websites or GUI programs. These applications consist of high-level interactions, such as user login or commenting. The data from these interactions is passed to Tier 2 through API calls or other requests. The second tier is the middleware, which interprets these events and puts them in a form required by the DBMS. Finally, the application layer uses specific libraries and drivers based on the type of DBMS to interact with them. The DBMS receives queries from the second tier and performs the requested operations. These operations could include insertion, retrieval, deletion, or updating of data. After processing, the DBMS returns any requested data or error codes in the event of invalid queries. It is possible to host the application, server, as well as the DBMS on the same host. However, databases with large amounts of data supporting many users are typically hosted separately to improve performance and scalability. Types of databases. Databases in general are categorized into relational databases and non-relational databases. Only relational databases utilize SQL, while non-relational databases utilize a variety of methods for communications. Relational databases. A relational database is the most common type of database. It uses a schema, a template, to dictate the data structure stored in the database. For example, we can imagine a company that sells products to its customers having some form of stored knowledge about where those products go, to whom, and in what quantity. However, this is often done in the back end and without obvious informing in the front end. Different types of relational databases can be used for each approach. For example, the first table can store and display basic customer information. The second, the number of products sold and their cost. And the third table, to enumerate who bought those products and with what payment data. Just going to check if I'm recording. Okay, I am. Tables in a relational database are associated with keys that provide a quick database summary or access to the specific row or column when specific data needs to be reviewed. These tables are also called entities, are all related to each other. For example, the customer information table can provide each customer with a specific ID that can indicate everything we need to know about that customer, such as an address, name, and contact information. Also, the product description table can assign a specific ID to each product. The table that stores all orders would only need to record these IDs and their quantity. Any change in these tables will affect all of them, but predictably and systematically. However, when processing an integrated database, a concept is required to link one table to another using its key, called a Relational Database Management System, RDBMS. Many companies that initially use different concepts are switching to the RDBMS concept because this concept is easy to learn, use, and understand. Initially, this concept was used only by large companies. However, many types of databases now implement the RDBMS concept, such as Microsoft Access, MySQL, SQL Server, Oracle, PostgreSQL, and many others. For example, we can have a users table in a relational database containing columns like ID, username, first name, last name, and others. The ID can be used as the table key. Another table, posts, may contain posts made by all users with columns like ID, user ID, date, content, and so on. We can link the ID from the users table to the user ID in the posts table to retrieve the user details for each post without storing all user details with each post. A table can have more than one key, as another column can be used as a key to link with another table. So, for example, the ID column can be used as a key to link to the posts table to another table containing comments, each of which belongs to a particular post, and so on. The relationship between tables within a database is called a schema. This way, by using relational databases, it becomes rapid and easy to retrieve all data about a particular element from all databases. So, for example, we can retrieve all details linked to a specific user from all tables with a single query. This makes relational databases very fast and reliable for big data sets with clear structure and design and efficient data management. The most common example of relational databases is MySQL, which we will be covering in this module. Pardon me. Non-relational databases. A non-relational database, also called a NoSQL database, does not use tables, rows, and columns, or prime keys, relationships, or schemas. Instead, a NoSQL database stores data using various storage models, depending on the type of data stored. Due to the lack of a defined structure for the database, NoSQL databases are very scalable and flexible. Therefore, when dealing with data sets that are not very well defined and structured, a NoSQL database would be the best choice for storing such data. There are 4 common storage models for NoSQL databases: key value, document-based, wide column, and graph. Each of the above models has a different way of storing data. For example, the key value model usually stores data in JSON or XML and have a key for each pair and stores all of its data as its value. The above example can be represented using JSON as the following. It looks similar to a dictionary item in languages like Python or PHP, example, key and value, where the key is usually a string and the value can be a string, dictionary, or any class object. The most common example of a NoSQL database is MongoDB. Non-relational databases have a different method for injection, known as NoSQL injection. SQL injections are completely different than NoSQL injections. NoSQL injections will be covered in a later module. Intro to MySQL. This module introduces SQL injection through MySQL, and it is crucial to learn more about MySQL and SQL to understand how SQL injections work and utilize them properly. Therefore, this section will cover some of MySQL and SQL's basics and syntax and examples used within MySQL and MariaDB databases. So, structured query language SQL. SQL syntax can differ from one RDB mess to another. However, they are all required to follow the ISO standard for structured query language. We will be following the MySQL/MariaDB syntax for the examples shown. SQL can be used to perform the following actions: to retrieve data, update data, delete data, create new tables and databases, add or remove users, and assign permissions to these users. Command line. The MySQL utility is used to authenticate to and interact with a MySQL or MariaDB database. The -u flag is used to supply the username, and the -p flag for the password. The -p flag should be passed empty, so we are prompted to enter the password and do not pass it directly on the command line since it could be stored in clear text in the bash history file. Again, it is also possible to use the password directly in the command, though this should be avoided as it could lead to the password being kept in the logs and terminal history. There shouldn't be any spaces between -p and the password. The examples above log us in as a super user, for example root with a password, to have privileges to execute all commands. Other DBMS users would have certain privileges to which statements they can execute. We can view which privileges we have using the show grants command, which will be discussed later. When we do not specify a host, it will default to the localhost server. We can specify a remote host and port using the -h and $P flag. Note, the default MySQL and MariaDB port is 3306, but it can be configured to another port. It is specified using an uppercase P, unlike the lowercase p for passwords. Note, to follow along with the examples, try to use the MySQL tool on your POEM box to log in to the DBMS found in the question at the end of the section, using its IP endport. Use root for the username and password for the password. Creating a database. Once we log into the database using the MySQL utility, we can start using SQL queries to interact with the DBMS. For example, a new database can be created within the MySQL DBMS using the create database statement. MySQL expects command line queries to be terminated with a semicolon. The example above created a new database named users. We can view the list of databases with show databases, and we can switch to the users database with the use statement. So show databases and use users. SQL statements are not case sensitive, which means capital use users and lowercase use users refer to the same command. However, the database name is case sensitive, so we cannot do capital, all caps, use users. Instead, we can use capital use lowercase users. So it is a good practice to specify statements in uppercase to avoid any confusion. Tables. DBMS stores data in the form of tables. A table is made up of horizontal rows and vertical columns. The intersection of a row and a column is called a cell. Every table is created with a fixed set of columns, where each column is of a particular data type. A data type defines what kind of value is to be held by a column. Common examples are numbers, strings, date, time, and binary data. There could be data types specific to DBMS as well. A complete list of data types in MySQL can be found here. For example, let's create a table named logins to store user data using the create table SQL query. As we can see, the create table query first specifies the table name, and then within parentheses, we specify each column by its name and its data type, all being comma separated. After the name and type, we can specify specific properties, as will be discussed later. The SQL queries above create a table named logins with 4 columns. The first column, ID, is an integer. The following 2 columns, username and password, are set to strings of 100 characters each. Any input longer than this will result in an error. The date of joining column of type date time stores the date when an entry was added. A list of tables in the current database can be obtained using the show tables statement. In addition, the describe keyword is used to list the table structure with its fields and data types. Table properties. Within the create table query, there are many properties that can be set for the table in each column. For example, we can set the ID column to auto increment using the auto increment keyword, which automatically increments the ID by 1 every time a new item is added to the table. The not null constraint ensures that a particular column is never left empty. For example, required field. We can also use the unique constraint to ensure that the inserted items are always unique. For example, if we use it within the username column, we can ensure that no two users will have the same username. Another important keyword is the default keyword, which is used to specify the default value. For example, within the date of joining column, we can set the default value to now, which in MySQL returns the current date and time. Finally, one of the most important properties is primary key, which we can use to uniquely identify each record in the table, referring to all the data of a record within a table for relational databases, as previously discussed in the previous section. We can make the ID column the primary key for this table. The final create table query will be as follows. So note, allow 10 to 15 seconds for the servers and the question to start to allow enough time for the Apache and MySQL to initiate and run. And we've got a question. We're going to spawn the target. And our question, authenticate with user root and password. Connect to the database using the MySQL client from the command line. Use the show databases command to list databases in the DBMS. And what is the name of the first database? So we'll just grab the IP address and reference our command. So it's going to be MySQL-U and then -p with no space password. And then our IP address, we need to specify that with our host, so -h. So we'll give that a shot. MySQL-U root -p password and our host. Extra space. Let's see if this works. Can't connect. Is it -p? Capital P, right? So usually it's 3306. It probably wants this IP address. I mean this port number. So 35673. 673. We'll just try this. Okay. So there we go. Without the space, logs this in right away. Not recommended. And then we're going to do show databases or show tables. Show databases, semicolon, enter. And it's asking for the first table. So we'll just copy that and paste that in. And carrying on. So SQL statements. Now that we understand how to use the MySQL utility and create databases and tables, let's look at some of the essential SQL statements and their uses. Insert statement. The insert statement is used to add new records to a given table. The statement following the below syntax. The syntax above requires the user to fill in values for all the columns present in the table. And in this one here, the example above shows how to add a new login to the logins table with appropriate values for each column. However, we can skip filling columns with default values such as ID and date of joining. This can be done by specifying the column names to insert values into a table selectively. Note: skipping columns with the not null constraint will result in an error, as it is a required value. We can do the same to insert values into the logins table. So insert into logins, username, password, and our values, administrator, and the password. We inserted a username password pair in the example above while skipping the ID and date of joining columns. Note: the examples insert clear text passwords into the table for demonstration only. This is a bad practice, as passwords should always be hashed or encrypted before storage. We can also insert multiple records at once by separating them with a comma. So two users. Query above inserted 2 new records at once. Select command. Select statement. Now that we have inserted data into tables, let us see how to retrieve data with the select statement. This statement can also be used for many other purposes, which we will come across later. The general syntax to view the entire table is as follows. Select asterisk from table name, semicolon. The asterisk symbol acts as a wildcard and selects all the columns. The from keyword is used to denote the table to select from. It is possible to view data present in specific columns as well. Select column 1, column 2 from table name. The query above will select data present in column 1 and column 2 only. The first query in the example above looks at all the records present in the logins table. We can see the 4 records which were entered before. The second query selects just the username and password columns while skipping the other 2. Drop statement. We can use drop to remove tables and databases from the server. As we can see, the table was removed entirely. The drop statement will permanently and completely delete the table with no confirmation, so it should be used with caution. Alter statement. Finally, we can use alter to change the name of any table and any of its fields, or to delete or add a new column to an existing table. The below example adds a new column to the logins table using add. To rename a column, we can use rename column. We can also change a column's data type with modify. Finally, we can drop a column using drop. We can use any of the above statements with any existing table, as long as we have enough privileges to do so. Update statement. While alter is used to change a table's properties, the update statement can be used to update specific records within a table based on certain conditions. Its general syntax is update, set, and where. We specify the table name, each column, and its new value, and the condition for updating records. Let us look at an example. So update login, set password as change password where ID is greater than 1. The query above updated all passwords in a record where the ID was more significant than 1. Note, we have to specify the where clause with update in order to specify which records get updated. The where clause will be discussed next. And our question, we're going to log in. We might still be logged in. So what is the department number for the development department? So what is the department number for the development? So we want to select all from development. It might be a different IP address. Let's just see. Should be the same. 356. Yep. Department. So let's see. So let's just try the select from select asterisk from. Let's go information schema and see what it says. No database selected. Use sys. Oops. Okay, let's kill this and hop back in. So show databases, use employees. You can turn off this feature to get it quicker. Okay, so then show tables. Show tables. And we're going to departments, so select all from departments. So we're looking for the development, I believe. So what is the department number for development? So there it is, department number D005. We'll copy that and paste that in. So we're going to go ahead and stop here for today. We'll continue with the rest of the SQL injection fundamentals next time. Once again, my name is Sleeper, and that's a wrap. Take care.